So to start out here, it says let f of x equal x squared minus x plus 1. Okay, so go ahead and write that function down. This is example 4. This is on page 310, toward the bottom of page 310.
Oh, okay, I got you.
And our function says let f of x equal x squared minus x plus 1. And we're on the interval from -1 to 4, which is going to be important.
My pen doesn't have a spring in it. The spring is just gone.
What?
I didn't take apart the pen.
Oh, it's there. It's right here.
What the?
I happened to find a spring for your pen.
Thank you. Oh no! I did not take apart the pen. The spring just was not in it anymore.
Someone's angry at you.
Yeah, I wonder how that happened. Seth?
What?
I didn't do it.
All right, now that Cohen's got his spring back in his pen, we're going to try this problem here. The mean value theorem says specifically, at some point, the average rate of change, which we'll denote by saying f of b minus f of a, this is y2 minus y1, over x2 minus x1. There's some value, f or c, that's usually how they write it. There's some value c where the instantaneous rate of change, or the slope of the tangent line, or the derivative, is equal to the average rate of change. So this guy over here would be instantaneous, and this one right here would be your average rate of change. And we're going to investigate or find all of the numbers c that would satisfy this conclusion. Okay. So first question here is what's b and what's a? How do we get those numbers?
Your two values in your window.
Yeah, they gave us an interval. So before we got to this particular lesson, they might have said, what is the average rate of change on this interval? In which case you would plug in 4 for B and -1 for A. Okay, so we could go ahead and do that. We could say f of 4 minus f of -1 over 4 minus -1. Is equal to f prime of c. This is what we're trying to find. Okay. Let's figure out what f prime is. What's that sentence? If we've got f of x equals x squared minus x plus 1,
2x minus 1.
then f prime of x is going to equal 2x minus 1. Right? And somebody go on your calculator, let's do f of 4. Maybe we don't need a calculator for this. We've got this. Look. 4 squared, 16 minus 4, 12 plus 1, 13. F of -1, we've got -1 squared, which is 1 minus -1, 2 plus 1, 3. Okay, so we've got a whole lot of information right here, and we can pretty much use all of it. Okay, so when we start plugging into this equation at the top, f of 4 is going to be 13 minus 3 divided by, let's do 4 minus -1, let's let that be 5, equals f prime of c. Well, we just found f prime of any value, f prime of x, to be what? So why don't we set that 2x minus 1 equal to our average rate of change over here? 13 minus 3 is 10. 10 over 5 is 2.
2 equals 2x minus 1.
So what is x that would make this true?
3/2.
Mm-hmm. when x is 3/2, our instantaneous rate of change is equal to the average rate of change, which is what?
The median value.
Right? But what is it? What's the slope of the secant line? 2. 2. So when x equals 3/2, the slope of the tangent line is also 2. You want to see a picture of that in action?
Yeah.
Nice.
Thank you. So right here, this is our function y equals x squared minus x plus 1. On the interval from a equals -1 to b equals 4, if you run a secant line through there, can y'all see that? The slope of the secant line is 2. That would be the average rate of change of this function on the interval from -1 to 4. If I found the derivative at this point c, this value c, which looks like to be 1.5 or 3/2, and I ran a tangent line at that point, the slope of the tangent line is also 2. Okay, so that's the mean value theorem. There exists a point, if the function is continuous and differentiable, where the secant line slope and the average and the instantaneous tangent line slope are the same number.
So the purpose of this is just finding where two slopes equal each other?
Find where that is. Mm-hmm. Yep, that's what we just did. Find where that is. So we found the derivative, 2x minus 1, and we set it equal to the average rate of change, and we said, where are they the same?
Is this just to figure out where they're parallel? Or
Sure, could find out where they're parallel. All right, so here comes example 6. Example 6. We skipped example 5 in the textbook. I think you already understand this, but we'll talk about it really quickly. It says, suppose a particle, in general an object, moves along a line so that its position at time t is given by s of t. The average velocity for the particle between t equals a and t equals b is some number. The velocity at the particle at the instant time t equals c is s prime of c. What this is telling us is, and I told you this yesterday, this is the same example that I've given you several times. If I am driving from here to Amarillo, and my average rate of change, my average speed on my speedometer is what? 75, sure. Okay, we're speeding again. The average rate of change between here and Amarillo would be 75. Then the mean value theorem says at some point on my drive, I actually went 75 miles an hour. Because how can I tell that?
Well, if you're speeding up
because it's a
constantly,
mean
and it's
value, which means it's somewhere in between, which means you pass through it at some point.
if you're not
Because the data is
continuous.
continuous. The mean value theorem doesn't work if we're not talking about continuous data. Okay? I gave a test to my 7th period this week, Tuesday. The class average was an 82. The average was an 82. Does that imply that someone in the class scored an 82?
No, that's not continuous.
It's not continuous data. It's discrete data. It's just that when I added them all up and divided, I got 82, the average. It's not implied that there was someone in the class who actually scored that because it's not continuous. Good? Okay. So let's go on to example 6. It says the MVT, the mean value theorem, and a maximum value. Suppose that f of 0 is -3 and f prime of x is less than or equal to 5 for all values of x. What is the largest possible value for f of 2? What is the largest possible value for f of 2? Okay. So in this case, we're allowed to say that the average rate of change on the interval from
2 to 0.
0 to 2
0 to 2.
would be equal to what? Right. If the function is continuous, then the average rate of change is going to equal 5 somewhere in that function. So we can solve for f of 2 working backwards there. Are you following? Okay, so let's set up our equation here. We know that f of 2 minus f of 0 divided by, so this is y2 minus y1 over x2, which would be 2, minus x1, which would be 0. We're going to use the MVT to find this point, f of 2. Because we can say that the average rate of change is going to have to be equal to f prime of x somewhere. And f prime of x on all values of x is less than or equal to 5. So at the very most, it's 5. So we can say, well, the average rate of change here, if we're finding the largest possible value, then we can set it equal to the maximum slope. Is that making sense? So f of 2, we're going to leave f of 2. We don't know that number. But we do know f of 0 is negative 3 over 2 minus 0, can we call it 2, is equal to 5. So can we solve for f of 2?
Yes.
How?
Multiply by 2, divide by...
So if I have f of 2 plus 3 all over 2 is equal to 5, I can multiply both sides by 2. And act like I didn't hear that. Put in the calculator. What? In what world? Insolve? Cuss words. What's f of 2? 7.
I never learned how to use it, so
Me neither.
I don't know how.
Yeah.
It's
It's super easy. Type in the equation.
Well, I don't know
Comma
like what
X.
button it is. I don't know. I just never used it.
Yeah, menu 3 1.
Okay. All right, so we found the largest possible value for f of 2. It would be 7. If f of 2 is 7, then the average rate of change is 5. Cool? Okay, moving on. So this is a pretty in-depth thought here. This says the mean value theorem can be used to establish some of the most basic facts of differential calculus. Okay, so this is the top of 312. First, we state a theorem that is a consequence of the MVT. Here's the deal. If f prime of x is 0 for all of the values in an interval, then what do we know about f?
It's a constant.
Then f must be constant. Okay? We already knew that. We already knew that the derivative of a constant is 0, but this is the only function defined on that value, on the interval, that all places have a derivative of 0 would be a constant. So this is kind of looking at it from the other direction. We already knew the derivative of a constant is 0. This is saying if the derivative is 0, then you're dealing with a function that is a constant. Okay? Anyways. Sometimes y'all just look at me like this. Okay, if you say so. All right. I don't think we need to walk through the proof of that. I think we're okay. But this is a very interesting thought here as well. So it says if f prime equals g prime of x. Okay, let's say that I have two functions. And both functions' derivatives are the same for all values of x on an interval from a to b. Then f minus g must be a constant. Thus, f of x equals g of x plus c, where c is a constant. Okay, so what in the world is this actually saying? I want to put a picture here so you can see. I had to come over here and manually take pictures in my textbook. This is a very good visual of what's happening here. It says if all of the derivatives for two functions are the same, then what you know is if you subtracted the two functions, you would find that they differ by a constant c, meaning the functions are parallel to one another, and their derivatives are only different by a constant. Okay, so it says let f of x, the big function f, equal f of x minus g of x. Then f prime is equal to f prime minus g prime. So two functions with identical derivatives must be only different by a constant. We can interpret this graphically. If two functions have the same derivative on an interval, then their graphs must be just vertical translations of each other. The graphs have the same shape, but they're shifted up or down. Can you see that? That's going to be very important when we move into the second semester and we start taking integrals. Then we can understand that a function might be the same as another function, just only different by the constant, right? It says on part 3 over here, be careful in applying this. The domain may be all the same, but f might not be a constant function. That means that they're not going to be the same on the whole interval. Okay, if you look at the function f of x, it's going to have two different branches. So you can't use that differs by a constant business if it's not the same. Okay. All right, let's go on to example 7. This will be the last example in this lesson. Really like this one. Move out of the way. Oh. Okay, it says show that for all x values, tangent inverse of x plus cotangent inverse of x is equal to pi over 2. Show that for all x values, when I add these two inverse trig functions, I should get pi over 2 for all of them. So write them down. Okay. All right, so the first thing we're going to look at is the derivative. Okay, so let's take the derivative. We've got f of x is equal to tangent inverse of x plus cotangent inverse of x. And our whole job here is to show that it's equal to pi over 2. For now, we're just going to look at it as a function. Okay, so let's first find the derivative of this function. Because it's a sum, it's not a product, it's not a quotient, it's not a chain, it's not any of that. I don't have to do anything fancy here. I just have to know what is the derivative of the inverse trig function. Okay? So anybody off the top of your head? What's it?
1 plus 1.
Yeah, 1 over 1 plus x squared. Good. Yeah. And what's the derivative of cotangent inverse? Negative 1 over 1. Yeah. So what if I just say minus 1 over 1 plus x squared? Whoa. That makes 0. Okay. Well, let's trickle back a few minutes ago. We said that if the derivative equals 0, then what?
Then there are just a translation.
It's constant.
Of the constant.
It's constant, right? So if the derivative equals 0, then f of x must have been a constant, right? F of x must have been constant. We didn't specify. We found that the derivative equals 0 on all values of x. We didn't specify on an interval. We didn't anything. We said for this function, the derivative is 0, period. So what that means is your function must have been a constant. Okay? Now, what constant? It says to find the value of c, let's let x be 1. You could pick any value for x, but it's easy if I do tangent inverse of 1. So we're going to let x be 1. And so now let's find f of 1. We're going to get the same number here no matter what I plugged in for x. But I think it's easiest to evaluate inverse trig functions of tangent at 1. So tangent inverse of 1 plus cotangent inverse of 1. Anybody doing a little unit circle over here? When does tangent equal 1? That's what it's asking. What is tangent inverse of 1? When is tangent, the ratio sine over cosine, equal to 1? When does that happen? 45 degrees, right? Also known as?
Pi over 2.
Nope.
Pi over
Pi over 4. Because that's the place where sine and cosine are equal. So the ratio sine over cosine would be 1. At pi over 4, you've got two mediums, square root 2 over 2 and square root 2 over 2. Because your leg lengths are the same, the ratio is 1. Everybody good with that? That happens at pi over 4. What's cotangent? Cotangent is the ratio of cosine over sine. So when would cosine over sine be 1?
Still pi over 4.
Also at pi over 4. Also at pi over 4.
Well, pi over 4 plus pi over 4.
Pi over 4 plus pi over 4 is? Well, how about 2 pi over 4? Which makes pi over 2. A quarter and a quarter makes a half pi.
And that's what the question asked.
And it said, show that tangent inverse plus cotangent inverse is pi over 2. We could have plugged in any value for x here. We knew that it was a constant because why?
Because it equals 0.
The derivative was 0. So then it was up to us to go figure out what was the constant. And you could have, a constant, you can plug in any value for x and you can find out what y is, right? It's easiest to plug in 1 because of the nature of these problems, or this particular problem. Any questions here at all? Okay. That's the end of lesson 4.2. Tomorrow is going to be a work day. We're just going to have some time in here to hash out. You've got 4.1 and 4.2 assigned. I don't know how much progress you've made on either one of them. Tomorrow's a work day. When we come back after Thanksgiving, we will do 4.3. I'm not going to start a new lesson tomorrow and then have to pick it up 8 days later. So we'll take tomorrow off. Those of you that are musicaling, be beautiful. Come back ready to work on Monday. Deal?